Okay, so okay, can you see the blank space here?
Yes.
Yes.
Okay,
Yes.
okay, first we discuss how. Okay, before that, what is energy transfer? Energy transfer means that when energy is transformed. Okay, when energy is transformed. Let's say that you have a lamp in your house, right? You supply with electrical energy and then will be changed to light energy, right? So this is the kind of energy transfer. Okay, I think you have learned this before, so it's easier for me to explain this. Okay, we are going to discuss that. Okay, try to compare between people in the past and people nowadays. Which one use more energy, you think?
Now.
Now, okay.
Now.
Okay, why? Why they say that? Why people nowadays use more energy?
Because everything in our days now is using a lot of electricity.
Okay, good. Okay, so energy nowadays, and in the past, right? So more energy here. Okay, but less energy is used in the past because we have more factories, for example, we have cars and so on. So this is very clear to us that energy is used more nowadays. So that's why you need to learn about energy. Okay, let us try to discuss a few examples of energy. Okay, now you tell me, catapult. Can you tell me the energy transfer in a catapult? You know what is catapult? Catapult. You know what is
Yes,
catapult? Okay, can
yes.
you tell me what kind of energy transfer in a catapult?
Um, energy,
What energy?
Kinetic.
kinetic.
Catapult has elastic material, right? Right.
Yes,
Yes.
Elastic. So we can say elastic strain energy. I just write E. Capital E stands for energy. Okay. Strain energy is converted to what? When you pull this the catapult and then you release it, what happens?
kinetic energy.
Kinetic energy. Okay, good. Kinetic energy. Okay, but in examination, please write completely. Don't just write E. Okay. Kinetic energy. Okay. The next example, burning gas in Bunsen burner. Bunsen burner. Okay, what energy?
Chemical, chemical
Uh,
energy,
okay, chemical
energy,
energy to
thermal energy,
okay, thermal energy, thermal energy or heat energy plus what?
light energy, light
Light
energy.
energy because you can see the light, right? Okay, other example. When you blow a balloon, what energy transfer is that? Uh, when you blow a balloon,
Chemical energy?
chemical comes from where? Okay, in this case, we are talking about the air that you blow into the balloon. When the air moves into the balloon, what kind of energy is that? What kind of energy is that? Kinetic, right? Kinetic energy here refers to the flow of air into the balloon. Okay, what is the energy transferred? What happens next? What happens to the balloon?
Um, bigger.
The balloon will expand, right? And
Yes,
what kind of material of the balloon? The balloon is
Yep.
elastic, right? So
yes.
what kind of energy now? We have
Elas
Ki.
strain energy, just like this one. strain energy. Okay? Understand so far?
Yes. Yes.
Okay.
Yes.
Okay, good. Okay, next example. Taking photograph. Okay, taking photograph. When you want to take, when the camera takes a picture, there must be what kind of energy? Light energy, right?
Kinetic.
It must, there must
Electric.
be light. If you want to take a picture, there must be light. Right? Right?
Right.
Okay.
Yes.
So first you must have
Yes.
light energy, and then at the end,
Sound energy.
when you want to produce the printed picture, so we need to have what?
Electric.
Chemical, because you know printed picture must have chemical, right? So
Yes.
converted to chemical energy. I know it is a bit weird, right? This example, but this is here in the book, so we can take it as an example. Okay, the next thing we will discuss is Sankey diagram. Sankey diagram. Did you ever hear the word Sankey diagram?
No.
No.
Sankey diagram. Okay, for Sankey diagram, we are talking about how efficient the energy transfer is. Okay, for example, okay, what is the main source of energy? Can you tell me in our life? You think what is the main source of energy?
Food.
Energy comes from where?
Sun.
Huh? The sun, right? Okay, energy comes
Sun.
from the sun. Okay, so energy. Okay, let's say this is the sun. Okay, so when the energy comes to us, okay, so do you think all of the energy from the sun reaches us or not?
Can you repeat again?
Okay, sun transfers a lot of energy, right? Do you think that all the energy that comes from the sun reach us, arrive at our place or not? Or it is
No.
missing somewhere?
No.
Okay, actually it's not all reach us. Okay, 30%, okay, 30% of the energy is reflected. Reflected because, um, you know, when you are at the moon,
The
you can see the Earth, right? Why do you see the Earth? Because the Earth reflects light from the sun. Okay, so some of the light energy is reflected. Okay, so 30% is reflected back to the space. Okay, and then 47% is absorbed by atmosphere. Okay, 47 is absorbed by atmosphere. Okay, and then 20% is used for water circulation. You know water circulation? You know, when light hits the ocean or the lakes, then evaporation occurs, right? Right?
Yeah.
Evaporation occurs, and then it will change to water again in the cloud, and then it falls as a rain. Right? It falls as rain, right? So this is water circulation. So 20% of sunlight is used for this reason. Understand?
Yes.
And then
Yes.
less than 1% is used to produce wind. Okay, to produce wind. Okay, because wind, we have wind because we have different pressure, right, from different places. The pressure because of the heat also. It happens from heat also. And only 0.02% is used for photosynthesis. Photosynthesis. Okay? Can you read my handwriting or not?
Yes.
Not very beautiful, but at least
Yes.
correct. Okay. So when we have this percentage of fraction of sunlight used, so actually we can represent it by Sankey diagram. Okay, so Sankey diagram is like this. Okay, let's say this is the sun, energy from the sun. Okay, hold on. Okay, this is the sun. Okay, energy from the sun. And then you can split it into a few arrows like this. Okay. Okay, so here's energy from the sun. Okay, from here, here's from the sun. And then 30% has been transformed for what? As I mentioned earlier?
This like reflection.
Reflector. And then 47
Absorb. Absorb.
absorbed by atmosphere. And then 20%?
Water circulation.
Water circulation. Okay, and then less than 1%
is wind.
to make wind. And then on the 0.02% is used for photosynthesis. Okay, this is what we call Sankey diagram. Okay, this is a Sankey diagram. Okay, any question? So actually, this is only one example, but actually this Sankey diagram applies to other situation also. For example, we have a lamp. Okay, let's say this is lamp, energy for lamp. Okay, sum of energy is transformed into heat, right? Right. Only sum of the energy is transferred to light. So this is what we want actually. Do we need the heat or not? We don't want the heat, right? So this energy is wasted. Only a small portion of the energy is converted into light. Actually, this lamp is electrical energy because we supply electrical energy to the lamp, and then some is converted to heat energy and some is converted to light energy. And we want the light energy, not the heat energy. Okay. Any questions so far?
No.
No. No.